everyone, welcome back. I'm doing English. I'm also known as DMA and appreciate when I'm called DMA. So today we have this integral to solve. Okay, so to solve this integral, x squared Euler to power 2x over x squared plus 2x plus 1, first we're going to need to apply some math trick here. Okay, so we know that x squared plus 2x plus 1 we can write in terms of a perfect square, right? Which is a squared plus 2ab, which is a plus b squared. We have x squared plus 2x, which can be 2 times x times 1, and this one can be 1 squared. So 2 times x is 2x times 1, 2x goes back here, so it can be written as x plus 1 squared. Okay, so if we can do that, then we can now say that we have x squared Euler to the power 2x dx over x plus 1 squared. Okay, and now where there is x squared, we can say x squared minus 1 plus 1. Okay, and now the question could be, why using this approach? Why? How do I know that I have to say x squared minus 1 plus 1? Because by implementing negative 1, I will be having difference of 2 squared. And in the difference of 2 squared, it's x minus 1 times x plus 1. So that x plus 1 can be simplified with the denominator to reduce the exponent of the denominator. Okay, so we're going to have now, this is going to be x squared minus 1 over x plus 1 squared Euler to the power 2x dx plus Euler to the power 2x over x plus 1 squared dx. Okay, so applying the difference of 2 squared on top, then that means we're going to have integral of x minus 1 x plus 1 Euler to the power 2x over x plus 1 squared dx. And for this particular part, we can keep it for now. So we're going to have Euler to the power 2x over x plus 1 squared dx. Okay, so we can simplify this with this one. So we're going to have integral x minus 1 over x plus 1 Euler to the power 2x dx. Okay, now we can apply by parts there. If we apply by parts, then for this integral we can call integral 1. So we have integral 1 here. Then that means for integral 1, applying by part, let's leave this part here. So we can say our u, it's gonna be equal to Euler to the power 2x. That means differentiating du, it's gonna be 2 Euler to the power 2x dx. And then our dv will be the remainder, which is 1 over x plus 1 squared dx. And that means v is going to be the integral of this expression, which is going to be x plus 1 to the power negative 1 over negative 1, which can simply be written as minus 1 over x plus 1. Okay, so then that means that integral 1 is going to be equal, if we multiply here, we're going to have we can just say minus Euler to the power 2x over x plus 1 minus integral v times du. That's what we know from by parts. So that's going to be minus 2 Euler 2x over x plus 1 dx. But this negative and this negative becomes positive, okay? That's perfect. That becomes positive. So, if we now check, this is the value of u1. Should we apply by parts here? Wait, calm down. Don't need to apply by parts now. Let's substitute where there is u1 by its value, which is putting there. So we're going to have, this will be equal x minus 1 Euler to the power 2x over x plus 1 dx plus the solution. I'm going to start by putting the integral first, which is 2 Euler to the power 2x over x plus 1 dx, and then this part here, 2x over x plus 1. Okay, now if we check in this integral, they both have the same denominator and they both have Euler. So if we factorize Euler, we're going to have x minus 1 plus 2, which will be 1, because minus 1 plus 2, it's 1. So in other words, we're going to get x minus 1 plus 2 multiplying 2x over x plus 1 dx minus Euler 2x over x plus 1. So this is x plus 1, they simplify. And what is the integral of Euler to the power 2x? Obviously, that's going to be 1 over 2 Euler to the power 2x minus Euler to the power 2x over x plus 1 plus c. So this is going to be the solution. So if you enjoy, leave your like, your comment, subscribe, and most importantly, share with your friends.